Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we have reached the last module of the part 1 of this course. Here in this module we will discuss the textiles for protection from air pollution, and the next module, next course, which is part 2, in that course we will start with the water pollution. So, here we will conclude the course with air pollution. So, first let us try to understand what are the different types of air pollution, how textile can help in protection, then we will go in detail of the filter fabric, different types of filter fabric, what are the how the filtration is evaluated and graded, that we will discuss, and mechanisms of filtration we will discuss gradually. So, here if we see the textile materials, we can see here textile materials are widely used for controlling the air pollution and to protect the human being. Although for water pollution also, along with the different other technologies, the textiles are also used. Now, let us try to see the overview of environmental pollution. So, if you understand the environmental pollution, then we can protect ourselves by developing suitable textile materials. So, if you see the environment are polluted by different ways, this is actually for the water pollution, the diagram is showing. So, here from the industry the gases, fumes are generated. So, that also add to the environmental pollution. So, it includes contamination of air, water, soil by anthropogenic activities. So, this is environmental pollution. So, when the air gets contaminated, water, soil, this type of things are getting contaminated. So, that as we are discussing the human protection in this course, so we are not will not discuss the soil, but soil can also be protected by using technical textiles like geotextile we can use. Our focus in this course will be the controlling the air pollution, protecting the human from air pollution. So, for air pollution, the major pollutant includes the particulate matters. So, we will discuss different types of particulate matters which actually floats in the air and it enters in our body through inhalation. Heavy metal, dye, these are basically responsible for water pollution, that we will discuss in the next course, and volatile organic compounds, this also generates air pollution, and pathogens are there mainly responsible for water pollution. So, for air pollution we express the concentration by milligram per cubic meter per 1 cubic meter, how much pollutants are there in the air in milligram, that is the expression, and in water per liter how much pollutants are there. So, that these are the expressions of environmental pollution. So, textile filtration material provide sustainable solution for pollution mitigation. So, basically we will see that if we use textile material, or we can use the sustainable textile material where it actually its environmental impact we can reduce by recycling or many other ways are there. So, what are the environmental impact? Let us try to understand, then only we can understand the how dangerous are these pollutants. So, fine particles there it can be expressed in different ways. PM 2.5, which means the particles up to 2.5 micron size. So, these particles actually penetrates deep into our lung and even blood streams. So, these particles are actually penetrate inside our body and which affect our health. WHO recommends annual PM limit particulate matter should be 5 micron per cubic meter. So, that is the limit for PM 2.5. So, very fine particles. And similarly, water pollution increases the BOD, biological oxygen demand, and chemical oxygen demand. So, that water pollution we should also prevent, and high pollution level. So, the presence of high pollutant which affect the human health, and also in case of water, if it is going to the soil, it will affect the disrupt the ecosystem balance. So, these are the great impact on environment as well as human health. Now, try to understand the role of textile materials in pollution control. We can see here. So, we can use textile material for air filtration, water filtration. By textile material we can use geotextile, we can use for erosion control on land filling, oil absorption. So, oil spill cleanup we can do. We can also the reduce the noise pollution. So, that we will discuss in a separate module. So, even odor control we can do within the textile material, within the filter we can incorporate odor control mechanism, that we will also discuss in detail. So, textile structure basically acts as porous media. So, that is the great advantage of textile material. This is a porous where particulate matter which comes along with the air or water, it gets entrapped within this structure and clean air or water can pass through. So, this is porous media. So, fibrous material capture the pollutants through mechanical and electrostatic interaction. So, mechanically depending on the pore size it gets captured. So, that is that detailed mechanism we will discuss later, and also by electrostatic interaction. So, we can charge the fiber, charge the filter material, so that it attract the pollutants, particularly for air pollution, and the particle gets entrapped. So, there will be, so this is the filter media, and say these are the particles coming through the air, say, or water, and few particles are escaping through this filter. Now, most of the particles are entrapped either within the structure or at the upstream surface. This is upstream surface. So, depending on the mass of these particles which are being coming along with the air and which are passing through the filter media, that ratio is expressed as filtration efficiency. So, if the filtration efficiency is high, so there will be no particle which will escape through the filter media to the downstream size. So, you can see here that is the eta is the filtration efficiency, C in minus C out by C in. C is basically it is a filtration efficiency. So, particle concentration before filtration inlet. So, this is a filter media and C in and C out. So, that is the filtration. You can concentration can be expressed in terms of mass per unit volume or maybe number of particles, that is also normally done, and C out is concentration after the filtration. So, that is how much percent is removed, that is the filtration efficiency. And one advantage is that high surface area to volume ratio enhance the pollutant absorption capacity. Now, let me explain what do we mean by a high surface area to volume ratio. So, if we take one fiber, this is one fiber, say coarse fiber, if you calculate the ratio per unit volume, what is the surface area? So, which is expressed as a specific surface area X S, which will be inversely proportional to the diameter of the fiber. So, this is S1 D1, another fiber we are taking say fine fiber D2. So, specific surface area S2 will be proportional to 1 by D2. That means, specific surface area of this fine fiber is much more than the coarser fiber. So, for a particular volume of or mass of the fiber, so this fine fiber presents larger specific surface area, and that will help in absorbing the pollutant. So, this on the fiber surface, the pollutants are adsorbed on the surface. So, higher surface if we can present to the pollutant and it will get absorbed. So, finer fiber will present higher specific surface area, that is why the filtration efficiency in case of finer fiber will be higher. So, this by manipulating the fiber dimension we can also change the filtration efficiency. So, classification of textile based filtration systems, that there are different types of filtration, textile based filtration. First is that textile air filter, which removes the particulate matters from air. So, wherever the air is pollutant, air pollution is there. So, we need air filtration. For water filtration we can use some type of textile membrane or textile along with some membrane for liquid purification, and also we can use the textile like composite we can use along with some chemical. So, it adsorbs the textile composite for chemical removal. For any chemical spilling we can use this by adsorption, and catalytic filtration textile for pollutant degradation. So, we can use some textile material with some catalyst impregnated on this. So, catalyst impregnated textile material we can use, and where pollutants, when it comes into contact with this material, it can get degraded. So, it is catalytic filtration, but the mechanism of all these four are entirely different. Okay. That we will discuss, particularly air and water pollution we will discuss in detail, what are the different types of mechanisms. So, what are the different types of fibers we use for filtration? So, particularly natural fiber, commonly used cotton, some cellulosic fibers like viscose we can use, wool. Okay. These fibers we use where hydrophilic properties are important, and synthetic fibers we can also use that little bit, they are hydrophobic like polypropylene, polyester, polyamide. So, these fibers are also used, and for degradable, that is biodegradable fiber we use for sustainability. So, even advanced fibers are used. These advanced fibers like carbon fiber, graphene coated fiber. So, these are used for some enhanced functionality. Even nanofibers are used. Nanofibers typically used for water filtration, and detailed experimental study we will discuss in the next course. And what are the different types of textile structures for this filtration. So, oven structures are used where the fibers are actually the fabric is required to block the particles in one surface within a particular. So, we can use we can control the warp and wave density to control the pore geometry. We can easily control the pore geometry depending on the particle size, we can control pore geometry. And nonwoven fabrics with random networks, that nonwoven fabric we can also use, and due to its random nature, the particles can be captured at the surface as well as within the structure, that is depth filtration we can use. So, here we can control, we can achieve very fine pore size. Knitted fabrics we can use, so where elastic pore structure, but main problem is that with the stretch, when it is stretched the pore structure changes. So, that will change the filtration efficiency, and porosity we can express by porosity of fabric. So, total void volume within the structure and total volume. So, that is the porosity. So, we can control porosity by different parameters in any fabric, like in case of yarn we can control the porosity by changing the twist, and in case of a nonwoven structure like needle punch, if we increase the punch density we can change the porosity. Now, try to see, we have two fibers that we have discussed earlier, how the pores can be changed. Now, if we use the coarse fiber, it will generate larger pore size. So, coarse fibers create larger pore, and where some small particles can pass through. So, that is the problem with the large size, but here if we try to use the large sizes, the advantage is that the pressure drop, the air will flow through easily, air will flow through, but the main disadvantage is that the small particle can pass. So, pressure drop is low, which is also required, but small particle can pass through. Now, here if we want for our requirement higher air flow, for that we have to use the coarse fiber, but at the same time if we want to increase this filtration efficiency, in that case we can use some additional treatment or additional process we can incorporate, like electrate charge, static electricity charging we can do, that is called electrate filter, where the air flow rate will be easy high, pressure drop will be low, but at the same time due to the static charge these fibers will attract the particles, that pollutants on the surface, and if we decrease the fiber diameter. So, for finer fiber we can see smaller pores we can generate, fine fibers create smaller pores and improves the capture, but the problem here is that here the air flow rate, pressure drop will be high for finer fiber. So, that is the main drawback of this system. So, smaller fibers increase the specific surface area, that is total surface area per unit volume of the fiber. If we use nano fiber, that is fine fiber, if we use, it captures ultra fine particle. So, less than 100 nanometer that fiber can be captured in case of nanofiber. So, filtration efficiency is inversely related to the fiber diameter. If the fiber diameter increases, filtration efficiency drops. But the main problem with the fine fiber, where the chances of air pressure is there, the pressure drop is there, the fine fiber will have difficulty. So, specific surface area is proportional to inverse of the reciprocal of the diameter, inversely proportional to the diameter. Now, try to see the pore size distribution in a filter media. So, its impact is that determines the particle retention capability. So, particle retention capacity. So, you can see the relatively the larger pores are there and medium pore, different types of pore sizes are there. Typical pore size of textile filter is 0.1 micron to 100 micron, that is a typical pore size of any textile media, typically Norwegian textile filter. Narrow pores distribution improves filtration efficiency. So, that is because if we the pore distribution is very high. So, that is variability is very high, then filtration efficiency will be dropped. As I have already mentioned, so if we try to reduce the pores, that means it will increase the pressure drop. So, air will not flow properly. So, the narrow pore distribution, if we try to distribute, this is the relative quantity. So, large pore and small pores will always be there, but the distribution. So, this is the relative pore size. So, this is the, if it is the distribution, then there will be problem. And if we distribute in this way, that is the difference between large pore and number and smaller pores, the relative quantity, if it is very high, then it will the filtration efficiency will be dropped. So, we can do surface functionalization, particularly for this water filter, we can use surface functionalization. So, if we see that this is the unmodified fiber and fine fiber that we have already seen this thing. Here we can do different types of surface modification, like hydrophobic coating we can use in any filter, like air filter also, air filters, and we can use hydrophobic coating which repels the water. So, water will not penetrate. So, that means for any mask, if we use outer surface or inner surface hydrophobic coating, that means it will not get wet. Normally outer surface we try to use hydrophilic coating also we can use, particularly for inner surface which absorb water, like our sweat it can absorb. Antimicrobial treatment we can also use to kill the microbes, and also electrostatic treatment, electrostatic charging we can do, electret filters. There particularly for coarser fiber we can use electret filter to enhance the filtration efficiency, keeping the pressure drop high, low pressure drop. Pressure drop high means for finer fiber pressure drop will be high. Now, functional group, different types of functional group we can use, COOH, NH2OH group we can use for different types of hydrophilic, hydrophobic, enhanced adsorption, we can also do plasma treatment, okay, to increase the surface energy, that is also we can do. Chemical grafting we can do to actually modify the surface structure, surface reactivity, where it can kill the microbes, different types of chemical grafting we can do. Surface wettability we can increase, so that can be measured by a contact angle. Now, let us see the different types of filtration mechanism, particularly for this air filter. So, one is the interception, when large particles follows the streamline and comes into the contact with the fiber, these fibers are intercepted within the structure. So, the detail we will discuss subsequently. Internal impaction. So, when large particle, so this is the fiber, so this is the fiber structure. Now, here a large particle is coming, it will strike the surface, fiber surface with high inertia, and that the fiber structure being the flexible structure, it will actually absorb the impaction and the energy will reduce, and the particle will get settled on the surface of the fiber within the structure or at the outside of the structure, the upstream side. So, that is also Brownian diffusion also is there in case of very fine particle less than 0.1 micron. So, this is the open structure of fibrous structure, textile structure. Now, the small particle will move at very low speed, even the particle size are less than the pore size, even though during this movement Brownian motion, during it when it is passing through the structure, the thickness, this particle will actually get impacted with fiber, that probability is there, and there it will get settled, because the velocity for Brownian diffusion it is very low. So, at slow velocity it is moving. So, the probability is that it will definitely strike during the path, it will strike with the fiber and get settled on the fiber surface. And so, overall efficiency, as we have discussed, this is the total efficiency, because we can add to all the efficiencies, all different mechanism. So, different mechanism will have its individual efficiency, we can get the total efficiency. Okay. Total efficiency is can be calculated. So, for each mechanism, so ith filtration mechanism we can use, or even at different layer, there will be filtration efficiency. Okay. So, that we can also calculate using this formula. So, it is a combined efficiency of multiple filtration mechanism. So, either multiple, because normally the particles are distributed at different size, distribution is there. So, it is not that always only one mechanism will work, more than one mechanism will work simultaneously. So, in that case we need to calculate the overall this overall efficiency. Now, what are the sources of air pollution. If we know the sources, so we can try to arrest those pollution or those pollutant at the source. So, let us try to understand the sources of air pollution. One is the industrial process, which releases dust and particulate matters like cement industry, coal industry, okay, power plant. They generate huge quantity of particulate matters and which floats on the air and air gets polluted. So, if we can use this filter at the source at inside the plant, that means the exhaust, the quantity of particle will be reduced. In the combustion process, some gases are released, so that those actually increase the pollution. Vehicle, then automobile actually exhaust, which actually contributes the PM 2.5 pollutants. The particle size are very small from the fuel exhaust. Indoor air contaminants, okay, bioaerosol and allergens, the different types of pollutants are there. Now, how to characterize the particulate matters? So, typically we characterized in two ways, PM 10 and PM 2.5. So, PM 10, the diameter or width of the particle, if we assume it is spherical. So, diameter of the particle is up to 10 micron. Whatever particles are there, the up to 10 that also includes 2.5 micron. So, that total mass, if we know, that will be PM 10 and PM 2.5 is less than equal to 2.5 micron. So, which 2.5 PM 2.5 is more dangerous because it reaches to our lungs easily, and also ultra fine particle less than 0.1 micron, which even penetrates into our blood. So, this is we have to protect ourselves from these particles through the textile filters. So, particle density influence the settling velocity. Now, air filtration, what are the different types of the different principles of air filtration? So, here fibrous medium we use to capture the particulate matters. So, filtration efficiency depends on the fiber diameter and packing density, like as I have mentioned, higher diameter fiber will create higher size of pores, and also if we pack this fiber, this it is open. Now, if we pack the same fiber closely, then pore size will be reduced and filtration efficiency will increase. So, that we can control the by fiber diameter or by packing density, making it compact. And if it is compact, then the pressure drop P1 is the upstream side, P2 is the downstream side. So, P1 minus P2 is the pressure drop. Higher pressure drop means you have to, this is the higher pressure drop means you have to use the higher energy. So, higher energy consumption will be there, because you have to flow pass the air through the filter medium. So, completely blocking means no particle will, we can use some say coating, lamination, say which is without any pores. So, in that case what will happen? It will not allow any particle, but main problem will be it will not even allow the air to flow. So, we should allow the air to flow smoothly or easily, but at the same time it should arrest the particles like our face mask. So, if we use the impermeable coating, impermeable membrane without any pores, then that is of no use, because we cannot breathe through that. So, we have to allow the air to pass through, at the same time we have to arrest or restrict the particles to pass through that. So, that is the main principle of air filtration. Even in case of industrial filter, there for cement industry, if we use completely blocked surface like no pores are there, in that case the air is not, air is should carry the particles. If air cannot flow, in that case there will not be any filtration also. So, if you see the Darcy's law, the pressure difference is expressed by mu L V and K. So, mu is the dynamic viscosity of the fluid, maybe air or liquid. If the air is little bit more viscous, like there is a moisture present or lower temperature, in that case the pressure drop will be high for same air. If it is totally dry, no moisture, so pressure drop may be reduced for same flow rate. L is the thickness of material. So, finer material, so keeping the same porosity, the finer material, in case of finer thinner material, the air travel will take shorter distance than a thicker material. This is thick, thin fabric. So, here the air travel will take shorter path. So, that will actually enhance. So, here as the air travel is taking longer path through the fabric, so pressure drop will be high. V, superficial fluid velocity through the medium. So, if we increase the speed, flowing speed, so higher speed will generate higher pressure drop. So, if we, that is why for a nanofiber coating or for very fine fiber structure with a micropores are there, this are used only where our air velocity is very small, and so where air velocity is very high, in that case we should use the open structure. Okay. That is why for clean room only one layer of this filtration will not work, we need a multiple layer of this filtration. So, first there will be coarse filter where air can flow at high speed, then gradually a very fine filter where we need a particulate, fine particulate matter to be arrested, and that will actually give you the very low speed, that we need very lower speed. And permeability of the porous media K. So, if the permeability is high, okay, then pressure drop will be low. So, we can get the permeability, maybe air permeability we can measure. So, that will give the idea about the pressure drop. So, higher air permeability of a medium, it will result the lower pressure drop. So, that we can calculate here. So, it decreases the fluid flow resistance, the air resistance will decrease okay, through porous textile medium. So, we can create a porous textile medium by for reducing the air pressure, which is important. Now, nonwoven textile filters are very important, very widely used for air filtration, because of the reason it will actually it will generate higher filtration efficiency, but lower pressure drop. The porous structure is there. You can see the multiple layer is used for filtration here. Now, you can see that clean air is coming out. So, nanofiber layer we can use to arrest the fine particle, mechanical filtration which will give arrest the dust and sand, coarse filter. Okay. So, dust, sand we can use the nano layer. So, multiple layer we can use here. So, typically for any filtration we use, in most of the cases we try to use the multiple layer to generate higher filtration efficiency. So, we can use the melt blown or spun bonding process to create nonwoven fabric. Like it gives efficient multi-layer filtration we can generate, it captures particles, gases, vapors also it captures there using the textile filter, nonwoven filter, and it is a lightweight, breathable, and we can use this ultrafiltration like mask we can use, HVAC or HVAC or air purifier we can use the nonwoven multi-layer filtration. So, advantage is that random fiber orientation enhance the interception, that is important. Like in case of woven fabric, the yarns are aligned in a particular order, and any particle less than the pore size, these are the pore size, any particle less than the pore size will penetrate through that. And if you see the side view of the woven fabric, this is the front view, side view if you see it is a very thin, and the air particle can immediately pass through, the particles present in the air can immediately pass through easily, which are smaller than this, and particles larger than this pore size will definitely be arrested at the surface. But in case of nonwoven, if we see the nonwoven structure, random structure is there, okay, and the thickness is also very high, this is the thickness. Now, you can see due to the random structure, the entrapment efficiency will increase due to the interception, it can intercept that within the structure. The aerial density, that is basis weight, is typically 200 to 100 gram per square meter, and these are basically respirators and air filters we can use. Now, the technology we use, melt blown technology is used, which generates very fine fiber, and that melt blown nonwoven is widely used for air filtration. Fiber diameter, you can see it is 1 to 5 micron, very fine diameter fibers are used. and fibers can be aligned in a very closed manner. So, their distance fiber, it is a compact manner we can generate, and which reduces the particle size and improves the filtration efficiency. So, melt blown technology is used. So, it is produced by high velocity hot air extrusion. So, it is extruded, polymer is extruded through the spinneret, and where through high velocity hot air is blown, which elongate the fiber, stretch the fiber further to make it very fine in diameter. So, melt blown is used in surgical mask. We will discuss later in detail the construction of surgical mask will, and spun bond nonwoven fabrics, it is a dimension, the diameter of the fiber is larger, where directly from the spinneret the fibers are laid randomly on a conveyor, and then it is bonded by either needle punching or by thermal bonding. Continuous filaments are coming through the extrusion. Fiber diameter typically it is a coarser little bit, 15 to 35 micron, it is a coarser fiber, but it gives higher mechanical strength. Melt blown, due to its finer diameter, its strength is typically lower. So, that is why the melt blown is used in sandwich at the inner layer. Okay. So, like this is the spun bonded coarser fiber which gives the mechanical strength, then the inner layer is melt blown, is spun bonded, and then another layer we use, outer layer, that is here it is another layer which is spun bonded, melt blown, spun bonded. So, in short we call it as SMS structure, spun bonded, melt blown and spun bonded. So, SMS structure, this is the melt blown. So, SMS structure is widely used for fine filtration with higher mechanical strength, mainly used for mask and other applications, and nanofiber filtration membranes are also used, which is produced by electrospinning. For very ultra fine particle arrestance we use nanofiber. Nanofibers diameter typically 100 to 300 nanometer. The main advantage of nanofiber is that its high volume to mass ratio, okay. High surface area is there, it is created here, where fine particles can be actually absorbed on the surface. And so, filtration efficiency for PM 2.5, very fine particle, we can achieve more than 99% filtration efficiency. So, nanofiber membranes can be used. The main drawback here is nanofiber is the strength is low. So, we need one substrate. So, on a nonwoven structure, on a stable nonwoven structure, we can deposit the nanofiber layer. This is a nanofiber, okay, and the substrate will give the strength. Pressure drop typically less than 100 Pascal. So, you can see the ultra fine nanofibers are deposited on any melt blown structure. So, melt blown is there, or here may be spun bonded. So, different types of combination we can generate, and the advantage is that it traps very small particle and pollutants, high breathability with low resistance, because we have created based on the very fine thin layer, but the melt blown or maybe spun bonded substrate is there. So, it will generate breathability, enhance durability and efficiency, because it is durable due to the substrate we have used, and it is used for mask HVAC air purifier. So, different applications we can use, and here this type of filter is used for dust, even for bacteria, like mask we can use, smoke droplets, it can arrest the smoke droplet, volatile organic compounds that can be used. Okay. Now, how to produce this nanofiber web? It is through the electrospinning process. So, this is the syringe pump is there, and so there is a polymer, okay. Some solvent we use, and here is a spinneret, and the what happens here, the high voltage is added. So, high voltage 10 to 30 kilovolt is applied to the polymer solution. Here high voltage is applied, and what happened? So, it forms the Taylor cone jet. So, it is the jet formation is the spinning spinneret, at the spinneret that the Taylor cone jet is formed, and continuous nanofibers is generated here, and it is deposited on a collection plate. Some substrate can be used. So, it enables controlled fiber morphology. We can control the diameter by changing the voltage and other parameters, and here you can see these are different types of pollutants are there, and that can be filtered out. So, next method is electrostatic filtration. So, charged particles, charged fiber attacks the particle via Coulombic force. So, you have what you have do, and you have a say coarse fiber you have used. So, it is charged, and the particle, say fine particle is coming, and it will be attracted on the surface. So, by electrostatic force, and which is actually expressed by, this is the electrostatic force Q1 Q2 divided by 4 pi epsilon 0 by r square. So, F is the electrostatic force between the charges, that there are two charges are there. So, F is there. So, Q1 and Q2 are magnitude of the two electric charges. So, this is a charged surface charge and the particle. So, this is one particle, suppose there is one particle. So, it is a here charge is Q1 and the particle is charged by Q2, and distance between this r, permittivity of free space. So, in the air what is the permittivity, and it explain the electrostatic attraction of particle charge on the fiber. So, that is the how much force, with how much force the particle is being attracted by the fiber. So, that we can, so if we charge the this fiber with higher quantity, that means it will attract more. So, that is the, but main problem with this, that electrostatic filtration, its charge decays. So, half decay time we can calculate. So, it with the time it decays, and also it is affected by moisture in the air. So, these are the different problems, but for short duration, for very critical application, we can use this electrostatic filtration. So, it is used for enhance the efficiency without increasing the air flow resistance. So, that pressure drop is not reduced, but you can enhance the filtration efficiency. So, we will stop here and we will continue with this in the next session, starting with the HEPA filtration system. Till then, thank you.